Assalamualaikum. Welcome to UMT Massive Open Online course. I am Siti Aisha Abdullah from the School of Marine and Environmental Sciences. I am a marine biologist, more specifically a marine botanist, doing work mainly on seaweeds and seagrasses. We will examine these aspects, and by the end of this topic, you should be able to identify and describe an estuary and understand the interactions among these characteristics. To achieve this, the topics will start with definition and classification of estuaries, followed by its major abiotic characteristics and their interactions. There are several definitions of an estuary, but the commonly accepted definition is as semi-enclosed bodies of water situated at the interface between land and ocean, where seawater is immeasurably diluted by the inflow of fresh water from land drainage. In an estuary, salinity may vary from 0.1 to 32 as the incoming seawater enters during high tide. Reach the middle zone by tidal processes, is mixed and diluted by freshwater from land drainage, and the characteristics of the estuary are further influenced by shape of the estuary. Characteristics of the estuary are further influenced by sediment deposition. Water parameters and sediment deposition are in a constant flux, making the estuary different from the adjacent freshwater and coastal ecosystems. Applying what we have seen, estuaries can now be classified according to how they were formed. Drowned river valleys were formed when rising water levels flooded existing water valleys and are characterized by low coastlines and wide plains. While fjords are formed by glaciers, are deeper and with a narrow opening. Bar-built estuaries are shallow basins partly exposed at low tide, enclosed by a chain of offshore bars or barrier islands, broken at intervals by inlets. Tectonic estuaries are formed when water fills land that had sank due to earthquake faults. In the estuary, tide determines the frequency, time, and duration of water influx, and extent of water influx. The difference in water height during high tide and low tide is not the same in all places, and this tidal range is used to classify estuaries, with microtidal estuaries having a tidal range of less than 2 meters and hypertidal with greater than 6 meters. Tidal currents are generated during the rise and fall of tides and determines flushing of seawater in and out of the estuary, including the distribution of floating and planktonic organisms. The combined effects of estuary shape, tidal pattern, and water height have led to estuaries being classified as wave-dominated or tide-dominated estuaries. In wave-dominated estuaries, a barrier at the river mouth restricts flushing, resulting in the trapping of sediments and pollutants in its broad central basin. Estuaries can also be classified as tide-dominated estuary, where its large entrance promotes efficient marine flushing. It has extensive intertidal and supratidal zones. Incoming tides bring in seawater into the estuary, thus salinity is an important factor. Salinity is defined as the total quantity of dissolved inorganic solids in water. Most of these dissolved solids are salts, with sodium and chloride as the most abundant. The higher the salinity, the greater the amount of dissolved inorganic solids in a volume of seawater. As a result, the weight of the dissolved solids is greater. Hence, the density of seawater is greater. When there is no turbulence, there is no mixing of seawater, and seawater stays at the bottom, compared to fresh water. Thus, there is layering or stratification. In the estuary, salinity at any point varies considerably over time. It varies from the river mouth until upstream, and varies also according to depth, particularly if there is no mixing, so there is stable stratification. As we can see, there is a salinity gradient from the mouth of the estuary going upstream. This is used to divide the estuary into zones according to the salinity range. The salinity gradient is used to divide the estuary into zones according to the salinity range. These values represent the salinity range organisms in a particular zone must adapt to in order to survive. Bringing together the interactions of topography, tide, and salinity, estuaries can be classified as salt wedge estuary, where river flow is stronger than tidal flow and stratification is stable. In a well-mixed estuary, river flow is lower than tidal current and mixing occurs, resulting in almost uniform salinity from top to bottom. While in a partially mixed estuary, mixing is not as strong as in the well-mixed estuary. Hence, bottom water is saltier than the surface. The reverse estuary is rather unique. The high evaporation during very hot season at the heat of the river results in hypersaline water, which being denser and sinks and flushes out of the estuary. This draws in water from the sea, which is less salty and dense than the river water. Both fresh water and seawater coming into the estuary carry with it sediment particles of various sizes. The larger particles settle out along the way until the flow reaches the center of the estuary, where it slows down, allowing the finest mud particles from seawater to settle out by biological aggregation or flocculation, and freshwater particles by sedimentation. Thus, the dominant substrate in the estuary is fine mud. Many other factors play roles in estuarine ecology. For this topic, we have defined an estuary, looked at the major abiotic characteristics, and how these parameters interact with each other. Knowing the prevailing environmental conditions in the estuary will allow us to understand the conditions faced by those organisms, that is, biotic components of the estuary, the challenges they face, the adaptations they have to make, and basically what it takes to live and survive in the estuary. This topic is followed by introduction to estuarine ecology before the flora and fauna of mangroves will be examined in more detail. Looking forward to seeing you again in my next presentation.